Well, thank you everyone for coming. This is my presentation, State of the Hardened Union. I want to first thank everyone for taking the time out of your day, for the sacrifice it takes to come here. Some of you have come from long distances, braved our nation's unfortunate borders, and I want to thank you for coming here. It's a large sacrifice on your part, and I want to thank you personally for that. So who am I? I am a senior security engineer and development team lead for Huntington Ingalls Industries. Huntington is America's, or the US's, largest military shipbuilder. I came into Huntington through an acquisition of a company called G2. G2 is a leader in its industry, and we deal with cybersecurity efforts. I'm the co-founder of HardenedBSD, and I serve as the president of the HardenedBSD Foundation. The HardenedBSD Foundation is a tax-exempt, not-for-profit organization, charitable organization in the United States. I focus mainly on offensive and defensive security, and especially as it pertains to human rights and anti-censorship work. I love to piss off those nation states that censor and oppress their people. I consider myself a perpetual noob. I try to learn something new every day. And I owe my life to those who contribute to open source. Being a college flunky, I learned and I studied, and I still do, off of your hard work. Thank you. And so this talk is dedicated to my wife and my 10-month-old puppy, who is 90 pounds and a lot of energy. So what we're going to do today is we're going to give a little bit of a background. I want to make this a personal story. I'm going to open up. I'm actually going to dive into my personal life in a little bit different of a way than I've done before. And that is to illustrate a story, because we're going to start with the story and we're going to end with the story. So then we'll talk about various exploit mitigations. And that story, we'll want to ponder that story as the presentation continues. How do these exploit mitigations change real-world events? Then we're going to talk about security postures, political, technical, and communal. And then we have a very special call for participation. And then I'll take questions and comments at the end. And actually, the vast majority of my presentation, I want to be more of a question and comment section at the end. After this call for participation, I would love for our audience participation. So back in my day, back in old country, in 2005, between 2005 and 2007, for a period of 2 years, I served a humanitarian mission of sorts, serving the Spanish-speaking people in Miami, Florida. I didn't get to choose the language. I didn't get to choose where I went. I was just told to go there, to immerse myself in the people and in the language and help them out. And I came across this lady. I helped this lady, rather she helped me. Her name was Marta, or we're going to call her Marta. She came from El Salvador, and she's an undocumented citizen. And she fled because she had a husband who died of cancer, and she lived in an urban, or non-urban, a rural area. And so she would work inside the home, and he would work outside the home, and together they would support the home. And they had 2 kids, a 3-year-old daughter and a 6-month-old son. Well, when the husband passed away, there was no more income coming into the house. So the cartel, MS-13, decided to kidnap their daughter as a form of payment to the cartel. You know, she couldn't continuously pay her membership dues, you know, her extortion. So they took her 3-year-old girl, sold her as a sex slave. She decided to make that journey to the US, that journey in which she would lose her 6-month-old son. When she came to the US, she still didn't feel safe. She still didn't feel secure. She was forced to marry an alcoholic, an abusive alcoholic, and she never felt safe or secure. I want to provide that safety and security to those who need it in the ways that I can. I suck with a hammer. I suck with an axe. I suck with physical labor. But I can type on a keyboard. So when I talk about security, this is personal to me. It's not a checkbox. It's not something to fill my resume with. It is to save lives. And so when we're humans, right? We write imperfect code. There's an argument that says, oh, we should just fix all the bugs and we're safe. We should fix bugs too. But we're humans. We're gonna still, even in looking for bugs, we're still going to miss some. So we need additional safety measures. We need exploit mitigations. So when we talk about security, when we talk about these exploit mitigations, what we're really talking about is making life more secure for others, saving lives. Way back, about 2 decades ago, the PaX team came up with NOEXEC. So that means that at mmap time, when we tell the operating system's kernel that we want to create a new memory allocation, that memory allocation can never be executable if it's writable, and it can never be writable if it's executable. And if the application requests both writable and executable, we silently drop the executable request. Because chances are the application's just requesting too much and they just want read and write, they don't want execute. At mprotect time, so when we're transitioning a memory allocation from one permission set to another, if the page is currently writable, it cannot be marked as executable. When the page is marked executable, it can never be marked as writable. And so these two features, when you combine them, they're called NOEXEC. And it commonly breaks just-in-time compilers like JavaScript, Java, and Python on occasion. So usually when operating system vendors implement PaX NOEXEC, they implement a method to toggle either mprotect or page exec at runtime. And so that's just one tiny little toggle. And so what that did is that means that That means that attackers can no longer, they can still inject their code, but they can't run it, because if they inject it into an allocation that's marked as writable, that allocation cannot be marked as executable. And so they can inject it, but they can't execute it. So the Openbsd model is that first half, really. It is at mmap time. And so essentially you just can't allocate memory pages that are both writable and executable. Due to a blog post that compared the implementations between HardenedBSD and Openbsd, Openbsd actually implemented the WX needed flag for both the file system and the binary. The FreeBSD model is more opt-in. With FreeBSD, what they're doing is the model is that an application will say when they are requesting an allocation at request time, at mmap time, they will say, okay, this is the maximum level of protections that this allocation can have. So maybe just read and write. So of these three models, the PaX model is the most strict, which causes the most headaches. We're seeing with HardenedBSD a lot of people that just get confused. They're users that want a secure operating system but don't necessarily completely understand or grasp the underlying technological concept, and that's fine. But it just means that there's a bit of a learning curve. And so it can trip people up, because Linux doesn't enforce this at all, really, except if you opt in with SE Linux or another Mac or PaX CTL, for example. There are multiple methods for opting in a binary in Linux. So the term now is kind of a generic term, WX or X, meaning if the page is writable, exclusively writable, or executable, never both. So W XOR X. So now to defeat W XOR X, we're going to assume for this slide the lack of ASLR. In 1997, we saw ret2libc, which effectively is ROP. ROP is no more than just a slight variant of ret2libc. So effectively, what we see is the emergence of code reuse attacks to defeat W XOR X. And that shows a need for both ASLR and SIG guard, because if the attacker knows where the address space or where the vulnerability lies inside of the address space, the attacker knows how to exploit it. It's pretty much game over. So with ASLR is a probabilistic defense against ret2libc style attacks. ASLR uses deltas, whereas ASR does not. ASLR is address space layout randomization, and ASR, you're dropping the layout from that. The reason to use deltas is primarily for performance, because the amount of security gain that you might gain from ASR is not worth it with regards to performance. When PaX, the dude who coined the term ASLR, implemented his first version of the patch, it was ASR for maybe all of a week when he was doing performance testings initially. Then he decided deltas were the right approach to use. So in order for ASLR to be effective, no fixed mappings may occur within the address space of the application. If there are fixed mappings, meaning that the application loads or the application has a deterministic address space, an attacker will use that to their advantage. And it requires compiling all your applications as position-independent executables. So for all of your non-Openbsd operating systems, statically compiled applications cannot be compiled as position-independent executables. There are tricks you can do to turn a PIC application, a non-Pi PIC application, that's hard to say, a non-Pi PIC application into a Pi. Wow, I just confused myself because of how hard that is to say that. A non-Pi PIC version can be turned into a Pi, but that's hacky and it's kind of stupid. Well, not stupid. It's cool research that's being done, but not recommended for production. So PaX ASLR is the strongest form of ASLR there is. On HardenedBSD, we have 5 different deltas for 64-bit systems. The problem that we're seeing is that ASLR, since it's now 2 decades old, or almost, it's nearly 2 decades old, it's been propped up on a pedestal, and a lot of security people don't really understand what it was originally intended for. And so we hear phrases like, ASLR is dead because it can be defeated in JavaScript. ASLR was never really meant for that kind of, to protect against that kind of attack. It's like me claiming, it's like me saying my leather shield from the Dark Ages, from the Middle Ages, is going to work against a nuclear shield. Like, no. So ASLR is meant to frustrate purely remote attacks, where the attacker cannot exercise the MMU, the attacker cannot perform other side channel attacks. It is a purely remote attack, or it is a defensive measure for purely remote attacks. So there are weaknesses, information leak vulnerabilities, certain format string vulnerabilities, and multi-tenancy shared trust. So when you are using virtualization as a form of, as a domain, protection domain, there are issues with that because you have those CPU microarchitectural vulnerabilities, because you have things, you are now trusting tech that ASLR was never meant to protect against or protect for. So over the past 20 years, ASLR has been put up on this false pedestal. When you take ASLR and look at it at face value and look at what it was meant to protect against with the weaknesses that were known at the time and even now, it still stands strong. PaX vGuard provides a deterministic defense against unreliable exploitation. When attackers are using automated tools to generate payloads, generally those applications, the victim applications or target applications will crash. And the user will probably just click to restart it, and they'll want to just restart the application as if nothing ever happened. So, so what we do is we track the number of crashes within a given window. And if the number of crashes exceeds a threshold, a certain threshold within that window, we then block further execution system-wide of that particular application for a given time period. It's similar to how you prevent password brute forcing. And it's available in NetBSD and HardenedBSD, but both operating systems have it disabled by default, I believe. Anybody from the NetBSD camp, is this incorrect? Okay, perfect. Because I tried to verify that, and I thought I got it right. So, so what we're seeing trend-wise is that the combination of ASLR plus WXORX plus SegVguard drastically increase the economic cost of successful attack, because now attackers have to chain multiple vulnerabilities together. So what we're seeing is abuse of function pointers, out of order execution like ret2libc attacks, data as code, using a picture with certain bits modified to cause this little bit of bit-rotted code to run. It's kind of fun. So in 2019, earlier this year, multiple vulnerabilities were introduced into the Telnet application. So even in 2019, we're introducing vulnerabilities into an application that really, it's old. There are valid uses for Telnet these days, but I would rather just shame those companies that require it. So what we're seeing also is that attackers are paying much closer attention to commit logs than defenders. Defenders, there's so much out there to defend. Millions and millions upon lines of code. Chrome, actually Chromium, the open source core of the Chrome web browser, has more lines of code, is comprised of more lines of code than FreeBSD, all of FreeBSD's base operating system. So what we're seeing is attackers are paying much closer attention to their targets than defenders are, primarily because defenders have a huge net cast around them. So with control flow integrity, what that does is that provides, that checks function pointers and indirect call sites, and that provides protections against code reuse attacks. PaX and GR Security have a solution called RAP. I believe that's Reuse Attack Protector. Microsoft has Control Flow Guard, and LLVM has CFI. And with the tech, the underlying tech is called CFI. So it's kind of confusing when LLVM's implementation is called CFI, the same name as the underlying just general name of the tech. So when I say CFI, I'm actually, for the rest of the presentation, I'm going to be referring to the LLVM version, because that's what is most relevant to the BSDs. Now, RAP is the strictest form of CFI. It is type-based, and they theorized it when PaX wrote the PaX Futures documentation. They hinted at type-based CFI. Control Flow Guard from Microsoft is too lax. So essentially, PaX's wrap is the best solution out there. Microsoft's control flow guard is too lax, and it's for Microsoft Windows. And we have LLVM. LLVM's implementation is decent. It is incomplete. There are ways to, there's a technique called control flow bending for object-oriented code. So there are ways to bypass control flow integrity, CFI. The implementation of CFI in LLVM is forward only, so that's protecting like function pointers and indirect calls, things of that nature. The CFI implementation in LLVM does not protect, it doesn't provide backward protections, so it does not protect the return value, return pointer. So how I see this is LLVM is likely the BSD's path moving forward. And as FreeBSD, HardenedBSD, NetBSD, Openbsd, and their derivatives, as they adopt LLVM, they will be able to take advantage of these compiler-based exploit mitigations. SafeStack is a deterministic defense against arbitrary code execution. It provides that backward, just had a brain fart, backward protections. So it does protect or make an attempt to protect the return pointer. Wow, that's just a. Oh, I'm sorry about that. I just. Anyways, okay, we'll move on. I'm also running out of time. So CherryBSD, really cool work coming out of the University Cambridge. They are focused on the hardware side of things. There is a software component side of that, but the core of CherryBSD's work is in hardware. It's effectively, the hardware has capabilities, even the address space. So you give capabilities, you teach the hardware about capabilities from a very core and fundamental foundational level. And I really, really like that approach. ARM is picking up at least some of their work. If I remember right, please correct me if I'm wrong, because I don't want to speak out of turn. But the problem is that we're seeing is hardware-based approaches to make any real-world impact. To make any real-world impact, it's going to take multiple decades. How long has it been since CET was announced? And we don't even have a chip out from Intel with CET yet. I think it's the next revision. But it's taken a long time to adopt certain bits of hardware-based tech. And what we need to help people right here and now, today. We can't wait for commerce to catch up to academia. We need exploit mitigations today. So from a technical security posture, collectively, the BSDs have come a long way. I've touched on a few things. Openbsd is doing more things like RetGuard and Carl and a few other things. We are paving the road in academia, especially with the CherryBSD project. There's a lot of good work coming out of there. We have solutions that span. We are looking into that future, decades into the future, what security is going to look like. And each BSD provides different solutions to reach similar or same goals. And I realized just the other week that it's really interesting that FreeBSD has ASR and HardenedBSD has ASLR. And with HardenedBSD being a derivative of FreeBSD, there's some interesting academic work that can happen there. How we can see how academia could probably take a look at how the two different implementations change that security posture. So there's some really good things that come out of even having downstream derivatives providing different implementations of similar goals or tech that has similar goals. The problem is that sometimes we're occasionally stuck in academia. We say, oh, we don't need X because we have Y, or X is dead. And that doesn't really do anything. That just ends the conversation and doesn't allow for creativity and innovation. From a political side, we are seeing, the BSDs are seeing that we don't really get advance notice of major vulnerabilities. Meltdown and Spectre, prime examples. There's an ongoing perception of violating embargoes. A lot of people think that Openbsd does. And I'm not one to say that they are. I don't have any evidence to say that they have. So from a political standpoint, there is a perception that the BSDs violate embargoes, and we need to prove them wrong on that, like we have been. Because the BSDs are differentiated, FreeBSD, NetBSD, Openbsd, and each are their own entity, we're not really considered a large enough audience like Linux is, because Linux is just a kernel, right? You have Linux. You have these distros of Linux, like Red Hat, blah, blah, blah. But at the core, it's just Linux. Not necessarily so for the BSDs. There's a bit of fragmentation with resources, human resources, when it comes to the BSDs. There's lack of vendor representation. Goes without saying. So from a community security posture, what we're seeing is the need for secure collaboration. That is going to be crucial going forward, that all of the BSDs can work together and securely collaborate. Fragmentation leads to that need for collaboration. Fragmentation leads to the need to build those bridges, not tear them down. So today, what we need to do is build that foundation of collaboration. Start even below the basement, maybe. Lives are at stake, remember. Some of these problems some of the real world and real life problems that people have, at-risk populations have, can be solved technologically, and we have the ability. We have both the ability and the means to save lives. So what HardenedBSD is doing is we're building that foundation for collaboration. And today we are putting out a call for participation among all the BSDs. We share history. We share code. We have immediate needs. We need to collaborate on these security issues. We need to let go of our egos. I'm saying that myself too. We need to incentivize fair play, that all the BSDs are treated equal. And that means equal among Linux, among Microsoft, among Intel, AMD, equal on all fronts. We need a centralized location for outside entities reporting issues because it's confusing. From a HardenedBSD perspective, if I want to reach out to Openbsd regarding a potential hyperthreading issue, who do I reach out to? I don't know. So what we're doing is we've set up a mailing list to start with. There's going to be more infrastructure involved, this mailing list is invite only for now. Please reach out to me if you want to be a part of this list. It is to fulfill those immediate needs and those long-term needs. The long-term needs are we need bylaws, we need code of conduct, we need a reporting strategy, a data storage strategy, pretty much everything. We're bootstrapping this from the get-go. And I need help with this. I need help, and all the BSDs need help. We need to get on this. We need to show the world that the BSDs are unified and can provide the world with secure and safe tech. 3MDB, or 3MDEB rather, is the first open source vendor on the list. They've partnered with us to be the first vendor to promise to work with the BSDs in mitigating security issues. So not only is this call for participation for the BSDs, but it's for the vendors as well. So let's piss off the bad guys together and make life safe for Marta at the same time.